Hey everybody, Phil Donahue here. This pre-calculus lesson is called the Rational Roots Theorem. Let's go ahead and do the board problem here. So divide using synthetic division and then state whether the binomial factor is a factor of the polynomial. Okay, so the box number here is -1. The box number here is 2. The box number here is -5. Okay, it looks like I have a couple of zeros missing in there, 0x cubed and 0x. Let's go ahead and do the first one, you guys. All right, so slide it down times the box number, add, times the box number, add, and then this times the box number, and then add times the box number. My remainder is 4. So if the remainder is not 0, then it is not a factor. Okay, its remainder is 4. Let's try the next one. Okay, here I get a remainder of 0, so yes, it is a factor. In fact, this factors some more. Factors of 3 that add to 4 are 3 and 1. So there's 3 roots to this. -3 I get on this one, -1 I get on this one, and then 2 was a root also right there. Okay, how about this guy? Looks like you get another remainder of 0, so yes, it is a factor. And then this one doesn't factor, and since that's an odd number, I would use the quadratic formula. If it doesn't say find the roots, but if it did, then this -5 would be a root, and then the quadratic formula gives me 7 plus or minus root 41 over 2 to be the other two roots. Okay, so the rational roots theorem allows us to narrow down the box numbers. Okay, the last lesson, we just were guessing on box numbers and looking for zeros. And fortunately, I set you up with some problems that the zeros were easy to find, but sometimes they're not. So what this does is lets us narrow down our possible box numbers in there. So okay, so here's a polynomial function. This a sub o is just a number like 10 or 33 or whatever, x to the n, and then this is x to the n minus 1, so all the way down to just a constant right here. Okay, don't let that confuse you right here. What this does is the factors are always the box numbers. Your possible box numbers are plus or minus the factors of this number over factors of this number right here. That's what this says. Factors of righty over lefty. You can disregard all the stuff in the middle. Okay, so for example, list all possible roots. So these are possible box numbers that would, so I'm going to do factors of the right number, factors of 2 over factors of the left number 6. Okay, so 1 goes into 2, 2 goes into 2, and then these are the numbers that go into 6. So 1 over 1, 2 over 1, 1 over 2, 2 over 2, which is 1, that's already covered, and then 1 over 3, 2 over 3, and then so on. So my possible box numbers are there. There's 2, 4, 6, 8, 10. There's 12 different possible box numbers. And I would try the integers first, 1, then I'd try -1, I'd try 2 and -2 and try to figure out which one gives me a 0. And then I get my condensed quadratic and I can solve my condensed quadratic. So let's go ahead and solve this, you guys. So I'm going to go ahead and try 1 first. And it looks like I get a remainder 12, not 0. So let's try -1. Still not 0. Let's try 2. Still not 0. Let's try -2. Hey, finally we got 0. So here's my condensed quadratic, 6x squared minus x minus 1. Okay, and then so -2 is a root. So now we're going to go ahead and solve 6x squared minus x minus 1. And that factors, you guys. It factors to 3x plus 1 to 2 times 2x minus 1. So I set these factors equal to 0 to get my other two roots. Okay, so here I get, when I subtract 1, I get -1/3. Here when I add 1, I get +1/2. And then don't forget the -2, the one that you got to get to 0. Okay, try this guy right here. Oh, I'm sorry. And then you can plug it in your calculator to narrow down your roots even more. When you plug it in your calculator and graph, look, here's -1, here's -2. Right there, I knew -2 was going to be a root, so I can plug it in to get my condensed quadratic to get the other two roots. But it's hard to see, but that would have been my -1/3. This is my +1/2. I would have plugged in -2 first. Plug it in your calculator, and that'll tell you which one of the integers will give you a root 0, and then that'll give you your condensed quadratic. So I'm going to use that strategy on this one. Find the roots of this guy. Okay, if I plugged it in my calculator, it tells me when I graphed it that 2 was a root. So when I plug in 2, it's going to get me a 0. I don't have that graph handy, but it does give me that it goes right through 2, so there's my 0. So now there's my quadratic. I'm going to solve that guy. Okay, that doesn't factor, but this is a complete in the square one. I'm going to take half of 8, which is 4. 4 squared is 16. Factor, and you get -4 plus or minus root 13. Don't forget the 2 was the other root right there. And that's it. Rational Roots Theorem is one of the fundamental theorems in pre-calculus.